Hey guys, if you enjoy my content, make sure to like the video and don't forget to subscribe to the channel. It helps a lot. Unit testing classes that use an HTTP client can be a pain. Along the years, I've seen various ways of dealing with this pain, varying from the creation of custom wrappers over HTTP client to not testing these classes at all. In this course, I will show you there's a pretty easy way to test classes that use an HTTP client. We will do this by gaining an understanding of how the HTTP client works and how to make use of that. Let's very briefly start with the basics of unit testing. In order to effectively write unit tests, we want our classes to be loosely coupled. To achieve loose coupling, we make use of dependency injection. To learn more about writing testable code, make sure to watch my video on the subject. In order to test classes that use HTTP client, we will create an abstraction over the declaration of the HTTP client. This will prevent tight coupling. And this way we can inject the abstraction in the constructor, which allows us to replace it with a mock for our unit tests. If you will be working with .NET Core 2.1 or a newer version of .NET Core, it is not required to create a custom abstraction. The HTTP client factory is perfectly suited. If you do not use .NET Core, or if you use an older version than 2.1, we are required to create our own abstraction. What we see here is the interface for the HTTP client factory that is provided by .NET Core. I will create a custom abstraction that I will keep as close as possible to the version of .NET Core. I will name this interface custom HTTP client factory, and I will give it a single method named create client, which has a return type of HTTP client. This is a good starting point to create the class library that we will be using throughout this course. We can add the interface that we just modeled and also create the implementation for this interface. Let's search for the class library template. I will pick .NET Standard because it has the most support. And I will name this mock HTTP client. Let's create it. I'll start by removing the default class, and then I will add the interface that we just modeled. It's called custom HTTP client factory. I will make this a public interface because this is the interface that we will expose to the outside world. Usually it's a good practice to expose interfaces to the outside world and to keep implementations internal. So that's what I will do for the implementation later on as well. This contains a single method that returns an HTTP client. The name of the method is create client. Okay, and there we have the interface. Now for the implementation, I will add a class which has an identical name minus the I at the beginning. So custom HTTP client factory. Like I said, I will make the implementation internal, and it will implement the interface that we created. Let's add the method. Now what we want to do is return an instance of HTTP client from this method. As I discussed in a video before, I will add a link to that video, is that we want to assign HTTP clients to a static field because we want to reuse HTTP clients instead of generating new ones for every request that we perform. So let's do that right here. So let's It's a private static read-only HTTP client, which I will name HTTP client, and I will instantiate it here immediately. And all we have to do here is return the HTTP client that we just declared. And that's all we need to do to create a custom abstraction over the creation of an HTTP client. So far so good. But how do we get control over the HTTP response message that is returned by the various REST methods of the HTTP client? To find this out, we need to know about the internals of the HTTP client. As you can see in the class diagram, HTTP client contains two constructors. One parameterless constructor and one constructor that takes an input parameter of type HTTP message handler. If the parameterless constructor is called, an instance of an HTTP client handler is created internally. This is then passed to the other constructor, which is possible because HTTP client handler extends HTTP message handler. Eventually, the handler is passed to the HTTP message invoker, and that is where the handler is executed and the HTTP response message is returned. The HTTP client handler performs the actual web requests. Because we do not want the web requests to be performed for our unit tests, we know the parameterless constructor is not suitable to get control over the returned HTTP response message. But what if we create a custom implementation of an HTTP message handler and provide that to the HTTP client? The HTTP message handler class looks as follows. Now this is something that we can work with. We simply have to override the sendAsync method and make it return an HTTP response message. We could provide the response message through the constructor and then make sendAsync return it. Now that we have a clear view of what we want to achieve and how we want to do it, let's start writing some code. Let's add a class for our custom HTTP message handler. I will name this class mock HTTP message handler. Again, this will be an internal class because we do not want to expose the implementation to the outside world. We need to extend HTTP message handler like we saw before in the class diagram, and now we need to implement the abstract class. There is the sendAsync method that we saw before. Like I said, we want to inject the HTTP response message through the constructor. So let's add that here and let's assign it to a field. Now for the sendAsync method, the only thing we want to do is return the HTTP response message. It has to be wrapped inside a task, and to do that I will return task from result, and then within I will provide the HTTP response message. And there we have it, the mock HTTP handler that we can provide within the constructor of the HTTP client later on. Everything is in place now to create a test for a class that uses an HTTP client. I created a pseudo code client that we will now test. You can see that it performs a GET request to an API using the client that is created by the factory. Lastly, it returns whether or not the response has a success status code. Pretty straightforward, but suitable nonetheless to test if we can get control over the response from the HTTP client. Let's add a unit testing project so we can start creating our unit tests. I'll add a project to the solution, and I will use an XUnit test project because I prefer to use XUnit. I will name this project pseudo client.test. And I will simply use the test class that is created already. I will rename this to pseudo code client tests. And I will also use the created test method. I just need to rename it, but let's first look at the scenario we want to test. Let's go with the happy flow. So if the client returns a response with a success status code, we expect pseudo code client to return true. Let's copy this because it's the subject under test. The scenario we want to test is the happy flow, and we expect pseudo code client to return true. Now let's create the arrange part, and we can now create a mock for the factory that we created. So the mock framework that I use is mocku. So I will install a NuGet package for that. And for the generic, I will pass I custom HTTP client factory, because that is the factory that we want to mock. And I will give it a mock behavior strict. And as you can read, that causes the mock to always throw an exception for invocations that don't have a corresponding setup. It's not that important for this test because we only have one mock, but if you have a unit test that contains multiple mocks, it can be very beneficial. So it's good practice to make it a habit to always add mock behavior strict, unless you have very good reasons not to do so. The factory returns an HTTP client that in turn expects an HTTP message handler. So let's start with the creation of the message handler. And herefore we will use our mock HTTP message handler. And as I say that, I realized that we made it internal because we do not want to expose it. I still fully stand by that, but I will make it public for now so we can quickly create our first test. I will change this back to internal later once we have refactored our code a bit more. But for now, let's just create it from here. And this expects an HTTP response message. So let's just create that here. And for the status code, I will give OK, because this is the happy flow where we test a success status code. And now for the creation of the HTTP client, we simply call the constructor. And we provide, as you can see here, the message handler that we just created. And that gives us the client. What we want to do now is make the factory return the HTTP client that we created here. So let's create a setup for the create client method. And we will return the HTTP client. So much for the setup. Now we need to create an instance of the pseudo code client so we can actually perform our test. So let's call this pseudo code client. We will create a new instance. For some reason it does not automatically suggest to add a reference, so let's do that manually. Okay. Yes, to the pseudo client. Now it is able to find it. And this expects an instance of I custom HTTP client factory, for which we just created a mock. Then I need to provide the object property. And there we have the client that we want to test. Now we are going to act. And we will assign the result of pseudo code client dot returns OK response async. And we need to make this an async method because the returns OK response method is also async, and we obviously need to await it. Now the last thing to do is assert the result, and we expect result to be true in this case, so I will simply use assert true result. And there we have our first test. The only thing remaining now is to run it, so let's do that. I will use the key combination Ctrl-RT. And as we can see here, the test passed. So we successfully created our first unit test. The second scenario that we want to test is the scenario where HttpClient returns a response message with a non-success status code, and we want to check if pseudocode_client returns false in that case. Because the test is pretty similar to our existing one, I will start by copy and pasting it. The subject on our test remains the same. The scenario changes to HttpClient returns non-success status code, and we expect the client to return false. Here we need to change the OK status code to a non-success status code like bad request, and we need to change the assertion to false. And that should be all we need to change. So let's run the test and see if it passes. And as you can see, it does pass. So with that, we have proven that we are now able to test classes that use an HTTP client. But what we have not yet achieved is creating a user-friendly way of doing so. And the reason I say that is because I don't really like what I see at line 38 and 39. Because in order to create an HTTP client that returns the desired HTTP response message, we need to create an instance of mock HTTP message handler, an instance of an HTTP response message, and an HTTP client. Let's improve this by creating a factory that helps us with the creation of HTTP clients. Because it concerns mocked HTTP clients, I will name this mock HTTP client factory. I will make this a public static class. The reason I make it public is because I want to expose this to the outside world. Now let's add a method. It will be a public static method that returns an HTTP client. I will name this create. And for the input, let's start off by taking an HTTP response message as input. And now instead of having to do it over here, we can move this part to the new method. And we don't have to create an instance of HTTP response message here because we get it from the argument. And instead of assigning this to a variable, we can simply return it. Let's make it a bit more robust by checking the HTTP response message for null. If it is, we will throw a new argument, null exception. And we will give the name HTTP response message. Okay. Now we have the create method, so we can change our unit tests. And let's see, We can completely remove this line, but let's copy this first because we will need it. And then we will still assign HttpClient to a variable, but instead of manually creating an instance of HttpClient, we will call the factory. So in this case, mock HttpClient factory, and then the create method. And we will provide an HTTP response message. For now, let's assign that to a variable. Okay, provide that new variable here. And there we have it. Instead of creating 3 new objects, we now only need to create an HTTP response message, and we can provide that as input to the mock HttpClient factory. So that's a bit better, but still, in my opinion, there is room for improvement, because why is it necessary for us to create an instance of HTTP response message? We are only interested in the HTTP status code, and in my opinion, the creation of the HTTP response message can also be moved to the factory. So let's go back and let's create another overload. It'll have the same signature, at least for the most part. The only thing that's different is the input. Instead of an HTTP response message, we will now take an HTTP status code. And now, instead of having to manually create a mock HTTP message handler and an HTTP client, we can simply call the existing create method. So let's return create, and it expects an HTTP response message. So let's create one, and we will provide our HTTP status code. And there we have it. Now we have the option to only provide an HTTP status code. So if we go back to our test, we can now remove this part. Oh, let's try that again. Let's remove this, and here we provide the HTTP status code, which was a bad request. Let's try again. And after waiting for a bit, we will see that the test still passes. So there we have quite a big improvement compared to how it was at the beginning. We now only have to provide an HTTP status code to the newly created factory, and we will get the desired HTTP client. We also have the overload where we can provide an HTTP response message, so we have the flexibility to decide which one we want to use. Let's also improve the first unit test that we created. But now we need to change bad request to OK. Let's run this one as well. And we see that this test also passes. Great. The only thing we still need to do is changing the visibility modifier of mock HTTP message handler back from public to internal. We can now do this because we expose mock HTTP client factory to the outside world. Mock HTTP client factory and mock HTTP message handler are part of the same project. So the factory can access the handler despite the visibility modifier of the handler being internal. So let's change this to internal. And let's build the solution again to see if it builds successfully. And as you can see, it does. And there we have it. A user-friendly library to test classes that use HttpClient. To really make it usable, we will need to create a NuGet package for it. That way, we can easily incorporate it within various unit testing projects. In my next video, I will show you how to create a NuGet package and how to publish it to both NuGet.org and to a custom NuGet feed. I will do this by setting up an automated build pipeline